I was just gonna do some practice problems for you guys. I know we didn't cover anything in the last class because we had a quiz, but we did cover free fall, so that's what I'm gonna go over today. So, these are from the books. She probably also has some of them on the slideshow. Okay. So you have this problem, falling from a tower. The ball is dropped. Drop tells you that V naught is gonna be 0. And I apologize that it takes me so long to write. I don't have a tablet, so I'm on the computer. If it said thrown, then that means it's gonna have an initial velocity. Usually it'll say like it was thrown so fast, and that's your initial velocity. Then it says from a tower, 70 meters high. That's gonna be your x naught. How far will it have fallen? That's gonna be x1, which is what you're gonna solve for. I'm gonna put a little question mark to mark that it's the unknown. After time t1, t2, and t3 seconds. So normally you would do like t2 minus t1 is delta t, right? Here's just asking after so many seconds. So your t naught is actually 0. And then you have 3 different times. So let me put that in text box so it'll be faster. You probably won't label them all as x1 just because that'll be confusing. So it'll probably be x1, x2, and x3. Just so you can keep track of what time you're calculating for. So then let me come back here and erase this one and put xn. Put that in red. And the n is what number you're working on. So then let's sketch this. You have a tower, which is gonna just look like a box. In mine, I'll put some, those are supposed to be windows. You have a tower, it's 70 meters high. Right? You have your ball. It's, put it in red. Ball, which gets dropped. Intuitively, you know it's gonna go downwards. Why? You're not sure. The answer would be gravity, which is a constant acceleration, right? So because you know that it's falling down, you're gonna have to know that your acceleration is equal to gravity. Gravity should be 9.8 meters per second squared. There will come a point where you basically have this memorized, and I'm pretty sure she's gonna expect you to have it memorized. So make sure you really drill this into your brain. But honestly, you'll use it so much that it's just gonna be there. Okay. And then you have T naught is equal to 0. V naught is equal to 0. And if you really wanted to, you definitely could set x naught as equal to 0. You would just have to define your axis. So let me do that as a little side note right here. X naught is equal to 0. Then the positive axis is downwards. If x naught is equal to 70, I have putting my units, my bad. Then the positive axis is upwards. And what I mean by downwards or upwards, now I want to draw. What I mean by downwards is upwards is if it's downwards, it goes this way, where this is your 0, this is your 70, right? And then if I say upwards, then it's going this way, where this is your 0, and this is your 70. Now note that acceleration for gravity acceleration by gravity is always going to head towards the floor. So the reason I didn't say downward is because if you're defining your axis as upwards, then downwards is going to be a little bit different. So acceleration by gravity is always going to be that way, right? Because you have the top of your building and you have the bottom of your building. So in this scenario, acceleration is positive. Right? And you can kind of prove that mathematically by thinking, okay, if you start at 0 and then you go for so too many seconds, right? If your acceleration was negative, that means you're going backwards, which would mean that you're going into the negative realm. But if it's positive, that means you're going with it. If it's like this, where 70 is the beginning, you're gonna be a negative acceleration, right? Because as you keep going, you're gonna have 70. If you have a positive acceleration, then your 70 is gonna keep getting bigger and bigger, which is not true because you're going against it. You're heading towards 0. So it's gonna be negative. Either one is correct. As long as you describe your axis, she'll be fine with it. Okay. I'm gonna give you guys a little pause. You guys can get that into your heads. I will eventually erase that. For now, let's try and figure out what kinematics equation we can use for this. Oh, right. So for me, I'm defining my axis as this one, where this is the positive, right? Because this is x naught. That way I can keep the x1, x2, x3 in order. So let me write that. Right, so this is my axis, where 70 is at the top and 0 is at the bottom. So then that means my acceleration is going to be negative. I'm going to put a little negative sign right there so I don't forget. Cool. So we have the few kinematics equations. Let me see if I stop it. I was going to just go over them. Should have, there they are. Well, you can't really see. Never mind. I'll just type it down. Okay. I'm going to use the one that we've been using the most. That's the x naught. X is equal to the x naught plus v naught t plus 1/2 a t squared. You guys should know this one. I'm gonna type it equal to x naught plus v naught t plus 1/2 a t squared. Change that to black. So then I'm gonna erase some of this. Do my work in green. So then we have t naught is equal to 0 seconds. So you don't need to do delta t because it's gonna just be your t1 anyway. So for all of them, we should probably get rid of some of these variables first. X is what you're solving for. So I'm gonna put an n here. And then it is a function of time, which is why I'm gonna put this t here. This also just helps you remember what variable you're plugging it in. Because basically when you write it down with an actual number, whatever's in here is your time variable. Your x naught is going to be 70, right? Because we're going to grab it from here. Your v naught is going to be 0. This one. I can get it over there. So that's going to be 0. It's going to cancel out basically. And then this 1/2. Your a is going to be your g. I can do that one in red since you've been doing it all in red. G. Put the little quotation marks to show that it's a. Actually, since we're just plugging, oh well, we have it. I'll put A and then put the G in later. So then that's going to become x of n, and this would probably technically be t of n. It's equal to 70 meters plus 0 plus 1/2 remember that your acceleration is going to be negative because I define my axis as 70 at the top. Note that if you didn't do that, you would just have to switch your x and with your x0. In this particular case, that means that your x naught would seem to be changing consistently, but it's just your delta x that would be changing, which is why I didn't want to do it like that, because it can be just a little confusing. Cool. So then you have your xn. I'm too lazy to do the t again. I don't know, shouldn't be. Then you're just gonna simplify, right? You have your 70 meters, which is your x naught. Because of how we defined it, that one's not gonna change at all. And then if you divide this by 2, that's gonna be negative 4.9. Wait. 9. That's a 2 squared, t squared. Cool. So then that's your equation. From there, you're just gonna plug in the different t's. I'm just gonna rewrite this 9. I'm gonna erase something. You guys got all this. Right, so that was our finding the equation that we're gonna use, putting it into the kinematics equation, and then getting only the variables that we want to use. Like this. It's all together. Oh, that's fine, I can do that one. Hey Samantha.
Hi Dee, how are you?
Good. No one else is here, so I was just doing a recording. I will definitely send it out on the YouTube, but let me just walk you through what I did. So we have a
Okay.
problem falling from a tower. It's 70 meters high. It dropped, which means that V naught started at 0, right? Because if it was thrown, then you'd have an initial V naught that was like a value. It also says right here that V naught is equal to 0. And that's how far it will have fallen at these 3 times. So then that makes you think that, okay, T naught is going to be equal to 0. And then I'm going to need 3 answers, one at T1, one at T2, and one at T3. Ignore air resistance is very standard for beginning physics because you just ignore it and it makes the problem a lot easier. So then we wrote down some of our variables over here. You know that T naught is 0 seconds, V naught is 0 seconds, and X naught is 70 meters. I wanted to brief blip about why I put X naught as 70. I think it would be easier to calculate for Xn that way. Because when you plug it into one of your kinematics equations, you can just leave it there instead of having to like move stuff around as much. Also because your positive direction is upwards, which is what this little arrow thing shows. Make sure my spotlight is on. This little arrow thing shows. That means your acceleration is going to be negative because it's going opposite of your positive direction, kind of. Let me actually draw that. Because you're doing acceleration from gravity. Which is always towards the floor, right? You don't have gravity making you go into the sky. And the reason you can double check with the math that this negative is correct is when you do the equation, plug it in and everything, simplify it out. You're gonna have your x naught minus something, right? And you expect to be minus because you're falling, so you're expecting that number to get smaller, not larger. From there, we're just gonna plug in the different times into this equation. So for x1, we're gonna have our t1, which is 1 second. And that is equal to 70 meters times the thing. I'm just gonna select it and copy and paste. Can I copy and paste? Oh, it's not. Gosh darn. Yes. I'm gonna do that part in text. Meters minus 4.9. You got the 4.9 by dividing gravity. Oh, that's what the mouse did. By dividing gravity into by 2, because the Buchanan mass equation is 1/2 AT squared. Squared times 1 squared. I'm gonna calculate it with a calculator soon, but I'm just gonna plug them all in for now. This caret sign just means squared. Or to the power of, because I put a 2, it's squared. And then we're gonna multiply that by 2 seconds squared. And then from there, we plug it into the calculator. $65.1 meters. Meters, right? You know that is meters because you can check the units. This one's gonna be meters minus meters over second squared times second squared So you know that these two second squares are going to cancel out. And then that's going to give you meters. Which you know is correct because that's the unit you're expecting for x. And then we plug in the next one, which is going to be 50.4. And then the final one, 3 second squared, 25.9. So you see that it's decreasing, which is what's expected. Now you want to find the distance that it's fallen. So like, right, it started at 70, which is x naught. Let me do that in a different color. It's not, and then it'll fall down to like 65, which will be 1. And then it'll be at like 50, which is the x2. And then down to 25, which is x3, right? So then to find the difference, you just do the delta x value. To x2 minus x1. Here you are going to expect it to be negative because we set the 70 as our like positive direction. I did it this way because this is the more typical way of doing it. Like it's the intuitive way. Yeah, the top of the building is 70. So I just wanted to make sure you guys knew how to do the signs for that. So then here, this is x2, right? In terms, let me not use numbers because we used a lot of numbers. It's final and initial. For all of these, the initial is the 70. But then the x final is either the x1, x2, or 3. Put F in on. All right, these are the x finals. And then we're going to subtract them by our x initial. Which is 70 for all of them. Equals negative 4.99 meters. Equals negative 19.6 meters. And equals negative 44.1 meters. Remember, they're expecting it to be negative because you're falling against the axis. Also notice that it's basically just the how far you went with acceleration, because the 70 meters kind of just cancel out by finding the difference. But it is helpful to be able to use the entire kinematics equation and then figure it out from there. Cool. I'm gonna go ahead and clear all of these drawings. So you have two platforms, but you're only looking at the second one, and it's 151 meters from the ground. So let me highlight that. So 15 meters. And then you're computing after position, velocity after so many seconds, and then at what velocity the trajectory. Okay. So we're just gonna say this is the platform, and then it's 15 meters above the ground. So now you can define your axis two ways. You can say, okay, this is my positive x-axis, in which case this one would be 115 up here, and it would be 0 meters down here. Or you can say, nah, this is my positive x-axis, in which case this is 115, nope, other way. This is 0 meters up here, and then 115 down here. What that
So
would do,
it would go like to the negative side.
yeah, but what this does is it lets you know how to use acceleration. Because your acceleration, which is gravity in this case, is going to be towards the ground, right? So in this instance, acceleration is the same as your positive x-axis. So then you're going to have a positive acceleration, right? Because as you get faster, you're going in the positive direction. So you're moving positively. And then this one's going to be a negative acceleration, because you're going opposite of it. So as you accelerate, you're going backwards in terms of the axis.
So I show both.
You show whichever one you're picking.
Okay, so basically
me-
in this question, it would be the negative one, this one, right? The one next to the 115 on this side, on the
You
left side.
definitely can. You can actually use either one, so long as you watch your signs.
Yeah. But wait, with her, with the question, when she asked, can we
Mhm.
write it on the same side? Let's say I put an arrow down,
Yeah.
for 115, and can I still put negative? The acceleration would be negative.
What do you mean? So
Like,
you put this like this, like with
yeah.
the people down here.
Is it because, okay, the acceleration is going down, it's positive, but then in the axes it would be negative, right?
For this
I don't
one
know.
right here, next to the red.
Yeah. Yeah.
No, I'm pretty sure acceleration is going to be positive for that one. Because if we remove the positive, like upwards and downwards, if we were side to side, we were going like this, and acceleration's like this,
Yeah.
then you're still gonna have a positive acceleration, right?
Mhm.
Because as you're accelerating, you're going to the positive direction. So your acceleration is making you go towards the positive, right?
Yeah. Okay.
Like if we were to have a velocity this way as well, that'd be a positive velocity, right? But if we were to have a velocity going backwards, then you're going backwards. We have a negative velocity. Right, same here. If you had backwards acceleration, you would have negative acceleration. Does that kind of make sense?
Yeah, kind of. It's because I'm only getting confused because I know in some questions, like it would be not the acceleration, but when it counts. I think the only thing that like confuses me is when it's showing the axes and it doesn't go accordingly when I draw, like,
Okay.
yeah, I
Well,
was just thinking about I was just thinking about negative because it was going down, and I was thinking about the quadrant.
You mean like in terms of these quadrants? What do you mean by quadrants?
Yeah, and it's
Like
going
these?
down. Yeah, so if it's going down, I just thought it's going down negative.
Yeah. That's why it's important to set your axis. You can definitely always set your axis so that it matches these if that's less confusing for you.
Yeah. Okay.
So in that case, we'll leave it as this one to the left so that it's less confusing for you. So we'll do this one as the axis. It is definitely more intuitive. That's the one that I picked when I was taking this class. And I would just recommend to stay on the same axis every time, just so you're used to it.
Yeah.
Okay. So then from here, you can basically assume, because it drops, you can assume that your V naught is 0. Right, and then because you set your axis the way you did, then this is x naught, and this is your x, and your x naught is equal to 115 meters. Cool. And then acceleration is gravity. And then gravity, you're gonna have to memorize. She's, I don't remember her giving it to us on quizzes. If I'm being honest, she might have given it to us like once, but it's a pretty common one to use, so. Square. Cool. So then from there, we can plug it into one of your kinematics equations. It's going to be the x is equal to x naught. I should probably do it on the other side. So we can put things in a little bit easier. T. And then plus 1 over 2 AT squared. Cool. So then you have your x naught, you're going to plug that in. You're also going to plug in acceleration, and then your v naught. V naught's going to be 0, so that's just going to disappear. And then you're going to insert the other ones. I'm going to do a mixture of text because text is faster.
Okay.
1. I'm going to put the 0 so you know that that's where the velocity was. And then I'll go back to writing this.
And this is for like A, right?
Yeah.
Okay.
Because you're going to plug T in as 3. So I can write that here. That's your T. Two. Don't forget, we have to have units. Seconds. I'm just going to plug it in because I don't want to rewrite it. 3 seconds squared. And then if you calculate that out, x is going to equal. I need to plug it into the calculator 1 second. 5 plus. It should equal like 159.1 meters. Right, and we can double check these units by going, okay, yeah, that's meters, that's 0. So you're not going to consider that, and then that's meters over second squared times second squared. So the second squared are going to cancel out. And then that equals meters. And then you just make a comment that like, but like unit is meters, which is what you would expect for x because it's distance. So then it says compute the position. You computed the position. That's what that is. So we can plug it in, or we can note it over here. It can fit. Probably leave it as 159 meters. It doesn't give you a crazy amount of sig figs. You get like 3 right here. This is a defined value, at least I believe so. So you don't really need to include that for your sig figs. So I would leave it at 3. And then from there, you're going to compute the velocity. I would use another kinematics equation. It's the one that goes, let me put A over here. A, B. The V goes to V naught. This one should be relatively fast because your V naught is 0. So that one's going to disappear. V naught is equal to 0. You're getting that from over here. It'll become 0. Oh shoot, wait. I made a mistake. This should be minus because your acceleration is negative. So then your actual answer would be 70.9. Do you understand why that's a mistake, what I did?
So, because of the acceleration being negative.
Yeah.
And
I
then,
forgot to put the negative sign.
yeah.
And so what did that do to my answer?
It changed it and it went down to 70.
Yeah, when I added the negative sign. But see this number, the 159? That's
Yeah.
above the platform, right? That's like this point
That's
went
too
upward.
much.
Yeah. It's like, oh, it started flying, which doesn't make sense. So that's something else that you check when it says, does your answer make sense? Is it like below the platform because you're expecting it to fall?
Okay. Sorry if you hear my smoke detector. I haven't changed my battery. And I don't know if you hear that beep sound.
Yeah,
I don't
you're
know if that ever
fine.
happened to you.
It happened. So then this one's just going to be plugging it into 9.8 meters per second squared. And then you're going to plug in T, which is going to be the 3 seconds. .8 times 3. which is going to be negative 29. You're expecting it to be negative because you're falling downwards relative to your axis. So it's like, yeah, it's going back. It's falling down, not up. And then the units double check that they're meters over seconds. Yeah, because this one's going to be canceled out by that, which is going to leave you with meters over seconds. Then we're good. The answer makes sense because yes, it's negative. Yes, it's in the right units. And it's not like crazy huge.
Okay, hold up.
Minutes, yes.
How'd you get 24? It's
It's 29.
never mind. Sorry.
You're okay. Thank you for interacting.
Why people don't interact?
Not really, no. That one
Really?
came, well, Sam came to the last supplemental, but then the last question, I started it wrong. So I'm gonna have to redo it, so I feel bad for her.
Oh, nobody goes on Thursday?
Some people went last time. No one went
I
on
know,
Friday. No one,
on
only Sam
Friday?
came. Yeah.
On Friday I didn't go because it was like I couldn't go. But I might go tomorrow. I was gonna say we could just
Yeah.
Um,
I'm honestly thinking of moving it
but if you
to
do
like
move it,
Tuesday or something. I didn't want to because I didn't want to have to take the shuttle.
like what would it be like 5 to 6 again?
What do you mean if I moved it?
Like if you move Friday, so it won't be Fridays no more?
No, it'd probably be Tuesday.
Oh, okay.
And then it has to compute the velocity with which the coin strikes the ground. Then you're gonna use another kinematics equation. You get to use all three on this one. I'm gonna use the one that goes V2. So you go to V naught squared plus 2a delta x. Remember that V naught is 0, so this one just goes away because it's 0. And then from there you can do the square root of both sides to get rid of that squared on the V. So then that will give you, I'm going to type it. V is equal to, open space, 2a, and then it's going to be x minus x naught. I'll fill it in with some. The square root symbol and the x naught. Right, a stays the same, and then your x naught is going to be that 155 meters, and then your x is going to be this 0 here. So then v is equal to the square root.
Oh my god, I hate using this fucking equation. I
I
hate that
know.
equation.
It's not the quadratic equation.
I know, but I feel like it literally like after this it is gonna be the quadratic.
Yeah, I don't like the quadratic either.
It's like so much work.
It does.
I feel like I was like the last 3 people literally yesterday.
And then x is 0. x naught is 115. I remember in high school when I was in calculus, people had the quadratic equation programmed into their calculators, and I was so jealous because they would
Oh my
just
god,
like,
those calculators are so like expensive.
yeah. I'm like, that's not fair. So just for the sake of units, I'm gonna leave it in the square root for now. 8 times basically negative 0.115. Get you negative 1. 6. And then note that the units are going to be meters squared over second squared, because you're going to multiply the meters from in here and the meters from the acceleration. Why is this still negative? It should be positive. I plugged into my calculator correct. I do
Wait,
not
hold
have
on.
to plus.
Let me do it too.
I accidentally added.
that should um, oh I know you took the square root to isolate the v, huh?
Yeah, to isolate the v.
Oh shit. What happened? Oh my iPad fell. Okay. Here's the longest question of my life. I just needed to get it because I was really struggling and I started studying and I have to study for PCAM.
Oh, yeah. So we got a positive velocity, which it should be negative because it's falling downwards. But then you have to remember that the square root actually has like a little plus or minus sign in front of it. So it can go either plus or minus. So you're just like, okay, yeah, it's supposed to be negative. I'm gonna put negative there. And then the units check out. And then for D, you just know that you had a constant acceleration throughout because it's acceleration by gravity. It wasn't like a variable, sorry, a function of time. So what you started with is what you ended with for acceleration. There we go. We should be recording now. So just for the recording purposes, we set our axis as like upwards is positive. Remember that at this tip point, you have v is equal to 0, and it's also your max height. And then you're setting this part right here as x is equal to 0. So this is your ground state, or like your floor, basically. So from there, I'm going to use the kinematic equation, v squared equal to v naught squared plus 2a So from here, you know that your x naught down here, because you're starting here, right? At a, is going to be
I
0.
was gonna ask, when will, you know how like there's a similar kind of this equation,
Yeah.
but when will we know which equation to use when it comes to free fall?
You look at which one has the variables that you have or don't have. So I picked this one because we're trying to solve for x, right? For how high it
Yeah.
goes. If I pick the other one, like let me see if I can scroll down. If I had picked, say, this one, right? We have x naught and we have v naught and a, but we don't have t and we don't have x final. So like, which one do I use? I have to solve for 2 variables and I can't do that with one equation.
Yeah.
I only have like one equation. So you only want to solve for 1 variable per equation.
Okay.
Right? Then if you were to look at the other one, yeah, you have v final and you have v naught and you have a. So you could solve for t there. Theoretically, you could use this one to solve for sorry, let me write it so you guys can see what I'm thinking. Could use this one to solve for t and then plug t into these, which is kind of where I messed up on the other one, because that's kind of just the long way around. Because even though you have only 1 variable here, you don't have x, which is x final, the variable that you're trying to solve for, right? And then for this one, there's no t's. So you know this one, you know this one, you know this one. You're trying to solve for this one, and then you know this one. That's why I picked that one. Does that make sense?
It does.
Cool. So yeah,
With
you look at
her,
the
it's like, we know how she gets like the full equation and she just derives it. She cancels
Yeah.
everything out. That's the only thing that's like confuses me sometimes. Yeah.
because she doesn't like explain how she picked that one.
No, she just derives from like the equation, the full equation. She derives it and she gets the equations that you chose. This one,
Yeah.
you know how she does it like that?
Oh
Like
yeah.
she rearranges it. Yeah.
Mhm. I think these are actually memorized. So I remember memorizing these. I'm like going back through my notes. When did she derive it? Yeah, I think these 3 you memorize, and then from there you can like cancel things out to figure out. So like in this instance, we know that we have our x naught is 0, so we're canceling that one out. And we know that our v is going to be 0, so we're canceling that one out. So then you kind of derive a new equation that 0 is equal to v naught squared plus 2a. So from there, you just sort of simplify and move things around. Right? Because you're trying to solve for x, so you can move v naught over this way. And then you're going to divide by 2a. That's going to give you negative v naught squared over 2a equal to x. So that's technically like an equation that you wouldn't memorize, but you have now. Is that what you mean?
Yeah.
Okay. Yeah, so she would usually pick one of the 3 ones and then from there cancel out units based on what she has and doesn't have. And then here you just plug it in. Right, you have your initial velocity is up here. And then you have 2 times your acceleration, which is gravity. That's down here. Hold up, the units aren't gonna be fine. You do the units right. Oh, it's squared. Right, because if we didn't square it, then the units would result in seconds instead of meters. Yeah. There, you just plug it into your calculator. Oh, this negative should probably be inside the squared. No, because the velocity value is not negative. It's just there's a negative in front of it. We're fine. And that's going to be equal to 11.48 seconds. And we know it's going to be meters. Oh. We know it's going to be meters over seconds because we have this meters over second squared. So that's going to become meters squared over second squared. And then it's over meters second squared. I like to do this little thing. Squared, second squared. The seconds are going to cancel out, and then one of these meters is going to disappear. It's going to leave you with meters, which is what you expect because it's distance. Does that make sense?
So you're canceling it out?
Yeah, I'm just checking my units here.
Okay.
And I actually typed it wrong.
I know you put meters per second.
This should just be meters. I'm going to go ahead and erase these. Right. So now that we have our x, we can calculate for time. And it's going to be a little weird because you could technically calculate for it twice, but you can use your x is equal to x naught whole equation. I guess where to go. You could use this one, that x is equal to x naught plus v naught squared. V naught t. It would work because you have x final, you have x naught, you have v naught, and you have a. But it's gonna take a little bit longer than if you were to just do this one because you have v final, you have v naught, and you have a. Either way, you're gonna get t, and you're gonna have to multiply t by twice. One time for going up and one time for coming down. Because if you were to put
Will I square it?
No,
Or
just
no?
multiply it by 2. Or add it twice. This here, look. Then you have the one time. That's going upwards. Oh, geez. It's going upwards. Right, and then you have another time that's coming back downwards. So that's going to be, because this is the x up here, right? That's what this is. This x that we solved for is max height. And you can't really do, okay, we have x is 0 and x is 0, because then your t is going to come out as 0. So you're going to calculate x is 0, x is at its max height, find t for that. Or you could do v and then v is equal to 0, and then calculate the t for that. And then you're going to technically do it again, but it's the same equation. So you're just going to add t twice. So t1 is this side. 1 is going up. And t2 is going down. So then t total is equal to t1 over t2. Does that kind of make sense?
Yeah, kind of.
Okay. So I'm gonna use the v's go to v naught because I think it'll be faster. This v is equal to 0. So we're gonna move. I'm gonna move the a over here because it's gonna be negative. Because right, that a is gonna be replaced by negative g. So you're gonna do plus gt. And then that's gonna let you have positive on both sides. You don't need to do that. I just like to because it looks nicer in my brain. It's less, oh no, so many negative signs. So then you're gonna divide by g on both sides. Get to t. 2. I wonder if I can type this. 15 meters per second over. It's gonna be positive now. 8 meters over second squared. This is gonna equal 1.5 seconds. And then your t total is going to be that times 2. So it should be like 3 seconds. Cool.
Yeah.
Nice. So then this is your value for A. This is your value for B. capital A, so you don't think it's acceleration?